Complex zeros and rational zeros of polynomials. Some of this stuff in this lesson is the same as the last one. So yesterday we talked about zeros. So what a zero of a polynomial p of x is a number r such that what happens when you plug it in? What do you get out? You get out 0. One thing we didn't talk about yesterday is something called the multiplicity of the zero. So sometimes zeros happen more than once. Like, so for example, if I gave you p of x equaled x minus 2 to the third, what is the zero of that polynomial? So the 0 at x equals 2. And the fact that this is x minus 2 as a factor 3 times, we say that that 0 has multiplicity 3. So the multiplicity refers to the number of times the 0 happens. It is the same as the power on the factor that it came from. Okay. All right, so find all real zeros of these functions and find their multiplicities. Okay, so what is the 0 of the first factor? 1. X equals 1. Does that one occur more than once? No, so let's not even state its multiplicity because it's just 1. There doesn't really have multiplicity. How about this one? X squared plus 4 equals 0 means x squared equals negative 4. So x equals plus or minus 2i. And those don't occur more than once either, right? How about from the x plus 5? What's the 0 there? Minus 5. And that has multiplicity 2. So in my opinion, you'll need to state the multiplicity of a 0 if it actually happens more than once. Does that idea make sense? Okay. How about this one? So I've got x squared minus 25 to the third power. Does that x squared minus 25 factor?
Yes.
Yes. How does it factor? X plus 5, x minus 5. And that whole business is cubed. Okay. So there are zeros at x equals negative 5. X equals what else? Positive 5. What is the multiplicity of both of those?
3.
3. Like if you were to list that x plus 5, x minus 5 to the third, you'd have x plus 5, x minus 5 3 times, right? So 3x plus 5, 3x minus 5s. How about the x squared plus 1 equals 0?
Plus or minus I.
X squared equals negative 1, yep, and so x will equal plus or minus I. All right. Do you see a pattern there between the zeros and the factors? So, like, this is what the next question is going to ask. So, for example, if I said that x equals 2 is a 0, what's going to be your factor?
X minus 2.
Your factor is x minus 2. Does that idea make sense? Okay, so we're going to use that we're going to have polynomials where we were given the zeros of them and we're asked to find the original polynomial. So do you see, okay, so find a polynomial of lowest degree with the following leading coefficients that has the indicated zeros, and write p of x as a product of linear factors and tell me the degree. So this has zeros at 4 and negative 4. So if you have zeros at 4, what has to be a factor? So 4 is a 0. You plug it in, you get 0, right? So you have to have x minus 4 as a factor. When you plug in negative 4, you also get 0. X plus 4. If you were to multiply those together, you would get x squared minus 16, right? The other thing says you have to have leading coefficient 5, meaning you want a 5 in front of the x squared. So what you do then is you put a 5 out in front, and that's your polynomial. And let's talk about some of the other things that the directions specified. They specified lowest degree, which means that you don't say x minus 4 squared. Yeah.
On like a quiz or something, do you want us to put it in that form, or like, can we also put it in the x squared minus 16?
Well, this says to leave it as a product of linear factors. Does that make sense? So if I say to leave it, you should leave it. Otherwise, I actually think you should multiply it out. So you could say, okay, that's 5 times x squared minus 16, or 5x squared minus 80? Yeah, okay. All right, so just a couple things. The lowest degree, that means that you put the lowest power possible on each factor, because technically, doesn't this one have the same zeros and also leading coefficient 5? So technically it does, but it wouldn't be of the lowest possible degree, because you could have ticked this factor down by 1 and just made it x minus 4 to the first. So technically there are lots of right answers unless they specify those things. So they're being very technical about this. If the question wants you to have repeated factors, it will tell you how many. Does that idea make sense?
Or could it do this in multiplicity?
Like it does in the next one. That's how they'll tell you how many. The next one says that you have a polynomial of lowest degree with the following leading coefficients. And so you have zeros of -2, which has a multiplicity of 2. So what is the factor that a 0 of -2 comes from?
Plus 2 squared.
X plus 2, and the fact that it was multiplicity 2 means it was squared. And if you have a 0 at 1, then that's x minus 1, right? And the multiplicity is 2, so that's also squared. They didn't say anything about the leading coefficient. I'm just going to assume they meant for it to be 1. I forgot to do this in the last one, but we should do it in this one. What is the degree of this polynomial going to be? Like if you were to multiply it all together, what would the highest power be? 4. Yeah, exactly.
Right. So even though they're different, x minus 1 and x plus 2.
The highest x will still be 4. I can show you why, okay? It's not hard. So if you do x plus 2 squared, what do you get? X plus 2 times x plus 2, what does that make? X squared.
Plus 4x.
Great. If you do x minus 1 squared, you get,
X squared minus 2x
uh-huh,
plus 1.
great, awesome. And then you just do massive distribution, right? And it helps a lot to be very systematic with this kind of thing. Like I would say, pick x squared, distribute that. Does that make sense?
Yeah.
Pick 4x, distribute that, and then distribute the 4th. So let's see what we get. We get x to the 4th, right? Minus 2x to the 3rd, right? So that's doing this, this, and then this, plus x squared. What do you get when the 4x distributes?
4x to the 3rd.
Uh-huh,
Negative 8x squared.
uh-huh,
And 4x.
great. And then the last one we should distribute is the 4.
And it's 4x squared
Uh-huh,
minus 8x plus 4.
yep. And then you see the biggest power there is x to the 4th.
You don't have to distribute. You can
Um,
just look at the highest powers and multiply.
That was my point. I mean, like, I think that we're just trying to explain to her why that is the case.
I'm just
But,
saying you could just say x squared plus junk, and then
yes. You could say like the highest power I'm gonna get here is from doing x squared times x squared, and so therefore the degree will be 4. But it is also really good to understand how to multiply polynomials like that and be systematic about it, because I find that most people, systematicness does not come naturally. Myself included, like I had to learn to think that way. Okay. All right.
The degree would be 2.
The other one, the degree would have been 2, exactly. Okay, this one's nuts. This is like, I looked at Alex and found examples of problems you were gonna be asked, and here was one of them. So find a polynomial f of x of degree 5 that has these zeros. We are definitely going to leave the answer in factored form this time. Okay, so if 1, 0 is negative 5, what's the factor? X plus 5? How about 0?
That'd just be an X.
That'd just be an x, yep. 1 would come from, and then we'd have an x minus,
4,
and an x minus,
7.
very good. Kapow, that's it. And its degree would be 5 because you have 1, 2, 3, 4, 5 factors. And there's no multiple multiplicities, that's also how you know, since it says degree 5. Nobody's like squared or anything.
So what if that said 6? Like, you would have to have.
If it said 6, one of them would have to be repeated, but they would really have to specify which one. Yeah, they would have to tell you which one had multiplicity 2, because otherwise there would be multiple right answers.
Okay.
Yeah, so that's a great question, but they would specify which one was degree 2. So yesterday when we were solving inequalities, we had something like, say, x plus 1 squared times x minus 1, and we found that it had zeros at -1 and 1. And let me just think, let's run through the sign chart for that really quick.
Where's this?
This is just an example to explain what's this whole even odd multiplicity business, okay? So just tell me, if you plugged in a number to the left of -1, like say you tested a number like -2, when you plug it into this, you're positive, plug it into this, you're negative, right? Does that make sense? So overall, you're negative on that subinterval. Here you test 0, and are you negative or positive there? This is positive, this is going to be negative, so overall you're negative. And past 1, if I test something like 2, you're going to be positive, right? So what this zeros of even or odd multiplicity is saying is that if a 0 has even multiplicity, then the polynomial has a turning point at R and does not change sign. Remember how I said if we were to graph this picture, you'd be negative, you'd go 0, you'd stay negative, and then you would go across? Do you see how this 0 had multiplicity 2? And while the function was 0 there, it didn't change sign. It was negative on one side and negative on the other side. That's what I mean by turning point at that point. And if the 0 is odd multiplicity, you're going to cross the axis and your sign will change on either side. Do you see what I'm saying? So in this picture, the -1 came from that x plus 1 factor, right? And whenever the power on that factor is even, the sign will stay the same on both sides of -1. Does that make sense? And if the power is odd, like this x minus 1 technically has a power of 1 that's odd, right? At its 0, the sign will change from negative to positive or vice versa. That's what that is saying. And the same thing is true if this had been like a power of 4. You still would have had the same no sign change happening. If this had been power of 3, you still would have had a sign change happening. So that's what that's saying. And it will let you take pictures and tell what the zeros were. So find a polynomial of lowest degree with leading coefficient 1, so I told you that has the indicated graph. Assume all zeros are integers. So this says 19 because the question was taken from your textbook. Can you find the zeros from the picture? Like, yeah, so what are the zeros?
1 and 3. And then
-2, 1, and 3. Exactly. And because they also do say lowest degree, right? So because the graph crosses the x-axis at both of those points, the powers on those factors that come from those zeros have to be odd powers. Does that make sense? They can't be even. So this is going to have to come from some polynomial that is x plus 2, x minus 1 times x minus 3. And its degree would equal 3. And I know this was on Monday, which was, really a long time ago. I feel the same way. We talked about how polynomials the number of turning points they have is one number less than their degree. Like parabolas, they involve x squared and they have a Gesundheit. They have a singular turning point, right? This picture has 2 turning points, which means that its degree is 1 more than its turning points. Yeah.
So, how do you know, like, what the peaks and valleys are when you're trying to make it, like?
Oh, how do you know, like, how high or how low these numbers go?
Yeah.
Calculus. You use something called a derivative to figure out the maximum and minimums, and then you can find them. So the way you find these highest and lowest points without calculus,
Just guess.
you plug numbers in and you guess. But there is a way to use calculus to find these highest and lowest points exactly, and that's a big idea in calculus. It's chapter 4, and it's like all the content of chapter 4 is like, how do you find those highest, lowest points? That's what you do. So.
I'm still a bit confused though. Why shouldn't there be a turning points at -2, -1, and -2, 1, and 3 because they're odd integer? Because you have odd integers. No wait.
I think I see what you're saying. No, the thing that determines the turning point is if the power is even.
Okay,
Okay, so.
I read that wrong.
Yeah, it's okay. It's tricky. So think back to that example that we had in the previous slide where I wrote down x plus 1 squared, x minus 1, right? The x at -1, there was a turning point because your function was negative, hit the axis, stayed negative. We'll have an example like that as well, okay? But think if you cross the axis, your power had to be odd. See what I mean by that? So at this 0, you had a sign change, right? You changed from negative to positive. You crossed the x-axis, that meant the power on that 0 is an odd number. You picked the lowest odd number. This one, you also went across the x-axis, right? Power on that factor is the lowest odd power. Here you also crossed, power is the lowest odd power. They're just giving you the zeros graphically as opposed to as a list. That really is all it is. And they're trying to get what does like a repeated 0 look like on a picture. So like this thing, where are the zeros? X equals -2 and x equals 1. And so that polynomial's got to have an x plus 2 factor, and it's got to have an x minus 1 factor. But because your polynomial does this thing where it goes down to it touches it and then goes back up again, that means that you had to have an even power on that factor. That's what a repeated 0 will look like in a picture. And same for that one. We can also check it with a number line, so this wouldn't hurt, I think, because I think you guys don't like this. If you put the zeros on at -2 and 1, and you checked something, so check a number to the left of -2, so like check -3. When you plug in -3, what is the sign of this first factor? Positive or negative? Positive. How about this next one? So overall, your picture is positive to the left of -2. Is that true with the picture you were given? Yes. Okay, test a number like 0. First factor positive, second factor positive. So overall your picture is positive there. You see how your picture is definitely above the x-axis, right? And then past 1, also positive, right? The specifics of where these turning points happen and stuff like that, like I think what you're thinking is, oh my god, how am I going to get this picture from this equation? Like that's a little bit confusing. To find these specific values of like that turning point, you got to know a little bit more math. So you're not gonna have to do that unless you're given more information. So I can't think of any way you're gonna have that in this class. They're just trying to get you to understand the relationship between if a graph crosses an axis, the power has to be odd, and if a graph just touches it, the power has to be even. That's the point. Okay, like this wacky one. Holy moly, okay, there are how many zeros? I think there are 4. So zeros at x equals, so what's this first one? and then, and then 0, and then 2. Okay. And then what you have to deduce from the picture is, was the 0 a repeated 0 or not? So at -3, was that one repeated? No, so that would be an x plus 3. At -2, is that 0 repeated? No, so x plus 2. How about the 0, 0? Yeah, so that'd be x squared. And then how about the last one?
Wait, why is x squared?
Because at that particular point, your function just touches the graph, it doesn't actually cross it. Yeah, when you have how you tell something's double root from a picture is if when your function hits that 0, if it stays both below the x-axis or both above. That's what repeated roots look like. If the power was supposed to be x, that graph would have to actually cross the x-axis there, and then, so if the picture had looked like this instead, if that would have been the picture, then it would have just been x.
Okay.
Yes, Tony?
So because it's the lowest degree, that's why we know we're putting a 1 or a 2, not a
No,
3 or a 4.
Exactly, yep, that's perfect. Yep, because they say lowest degree, that's why we're putting a power of 1 on these, because technically speaking, if they didn't say the power of 3 would also do the same thing. Yep, that's how you know it's just one of them. And that's also why we're using 2 here and not 4, because 4 would yield the same kind of behavior near 0. Yep. Okay. But my main point was, how do you find zeros from a picture? And then if the picture does this kind of touch and go back down or touch and go back up, that means it was a repeated 0 of some type. To know if it was repeated as a 2 or a 4 or a 6, then you've got to be given more information. But since they say lowest degree, then you know it's just 2. Okay. All right, so this question was a little bit goofy, but it said find all y-intercepts and x-intercepts. And the thing that I thought was goofy is they said intercepts for the y. Can a function have more than one y-intercept? No, it's only going to be one, so let's do the y-intercept first. So how do you find the y-intercept? What do you plug in? 0 and for x. Great. And so if you plug in x equals 0, you're going to get y equals -16. So you've got the point 0, -16. Okay, x-intercepts. For that, you plug in y equals 0. Those are the harder ones to find. And I think I said, we discussed yesterday, that there is occasionally a trick for factoring stuff that has 4 terms and powers of 3, and that's that grouping trick. I'm going to also discuss how you might approach a problem like this if that grouping trick doesn't work today. So this one, I'd say you should always try it if you see 4 terms, because I probably gave you one of those. What's the greatest common factor of those first 2 terms? X squared for the first 2. And the second 2 is -16, and that becomes x plus 1, right? So because those linear factors match, you know grouping works, and woohoo! No one else seems excited. Okay, just me. X squared minus 16 times x plus 1, right? And then will x squared minus 16 factor anymore? What's it factor into? X minus 4, x plus 4. Okay. And so what are the numbers that make that 0? Yep. So, and those as ordered pairs technically are the numbers -4, 0, 4, 0, and -1, 0.
On a test or quiz, do you want them in?
I'm going to have to specify that I want them as ordered pairs, and I can't remember if I did or not on your quiz, so officially I probably wouldn't have you docked if you didn't. But I just have so often had students not understand how to plot them once they found them. I think it's important to emphasize that the other coordinate is 0. Okay. Try the next one, okay? See if you can get it, because it's the same idea. There's also a grouping factoring going on. I'll charge my Apple Pencil. You guys give it a try. So did you get 2, 0, negative 2, 0, and negative 5, 0?
Yes.
Yeah, okay. If you were to graph this picture, would your function cross the axis or just touch it and turn around at those zeros? It'd cross because the power on each of them is 1. Okay. All right, so now the question is, so for the next one, let's try it. And let's try to solve this by factoring by grouping and see and discuss why that doesn't work and talk about what else we're going to do. So if we try to factor this by grouping, and we say take out from that first group x squared. For the next group, what's the GCF? 1, right? You see how these factors don't match? And so if that happens, then that trick doesn't work. Okay, so grouping no go, sad face. Don't try to make it work, you're gonna be wrong, right? Like so, it just doesn't work, give up and try something else. I mean, give up on that, don't give up completely. So now, the other information that I would give you in this case, if grouping did not work, is I would tell you one of the zeros. And so we know that if negative 2 is a 0, what number is a factor? X plus 2. Okay. Now think about numbers. If I say that 5 is a factor of 20, when I do 20 divided by 5, I get an even number and no remainder. Does that make sense? So we're going to actually use that idea with division to factor this down. So what we're going to do is we're going to take the factor that we know works, and we're going to divide x plus 2 into this x cubed plus 6x squared plus 7x minus 2. And there won't be very many of these because they're pretty tedious. I get that you have lives and don't want to do math all the time, but you've got to know, okay, well, if I have a factor, it's going to divide evenly into the thing. So if you don't get a remainder of 0 with this, you did something wrong. Okay? So you must get remainder 0. You should. Okay, so this good long division review. What do you multiply x by to make it match the x cubed? X squared. Spectacular. So it'll be x to the third plus 2x squared. If you're going to make a mistake, it's in the negative sign stuff, so just be very careful with parentheses and negatives. Gesundheit. So what's 6 minus 2x squared going to be? 4x squared, great. Bring down the 7x, and you don't have to bring down the negative 2 yet. All right, what do you multiply the x by to make it match 4x squared? 4x. So 4x squared plus 8x take it away. So the 4x squareds cancel. What's 7x minus 8x? Minus x. Minus 2. And then what do you multiply x plus 2 by to make it match -1? Take it away and you get a remainder of 0, right? And so what that means is your original function f of x is equal to x plus 2 times x squared plus 4x minus 1. Does that make sense? Okay. So there's your first step. Now, if this next polynomial factors, spectacular, factor it. Does that thing factor? No, evilness. So here's how you'll express it as a product of linear factors if factoring does not work. What you have to do now is take the x squared plus 4x minus 1 and find its zeros. I know. So good completing the square review, right? Like these things keep coming up over and over again. X squared plus 4x would equal 1. What number do you add to both sides? 4. X plus 2 squared equals 5, right? So x plus 2 equals plus or minus root 5, right? And so x equals -2 plus or minus root 5. Is that okay? All right. And if those are zeros, then your factors are x plus 2, x minus one of them, -2 plus root 5, and then x plus another one of them. Oh wait, that's wrong. X minus 1 and x minus the other. Where's my eraser? It's not available. Well, that's stupid. Okay, backtrack a second. So this tells you that you have a 0 that is at -2 plus root 5, right? And if I plug -2 plus root 5 into that factor, does it zero out? Does that make sense? Like if you had x equals, you had 1 0 at -2, right? The factor that came from is x plus 2, right? Okay, so your other zeros are x equals -2 plus root 5. Another one is x equals -2 minus root 5, right? When you plug those in, you should get 0. So when I plug -2 plus root 5 into this thing that I just wrote down, does it zero out?
Yes.
It's something minus itself, right? So then what would the other one have to be? X minus, what's the other 0?
-2 minus root 5.
-2 minus root 5. And there it is as a product of linear factors.
What do you mean by zeros out? It's -2 plus root 5 is
Uh-huh.
0.
When you plug in -2 plus root 5 into all of them, this one will become 0. So if you have -2 plus root 5 minus -2 plus root 5,
Okay.
that zeroes out. And with this one, when you plug that one into that last factor, that also will zero out, right? So that's how you deal with it if you have zeros that are not whole numbers. Does that make sense? I care less about those than the ones where the zeros are whole numbers. I think they're more common. Does that make sense? You could also distribute those negatives. Does that also make sense? Okay. I didn't mean to make that one quite so complicated. In my notes, I stopped at the division step. So. Okay, so the question that this kind of begs is, they told you that -2 was a 0, right? How the heck would you figure it out if you weren't told that? Does that idea make sense? And one thing that you can do to get a list that's finite of possible zeros is use this thing called the rational zero theorem. I'm not going to even begin to explain why, it's to just tell you what it is and how you use it. So if you have a polynomial like this, where the leading coefficient is not 0, and if you have a rational number b over c in lowest terms, then if it's going to be a 0, this number b must be a factor of the last number, and that number c must be a factor of the leading coefficient. So let me just say that one more time. You have a rational number b over c that is a 0 of this polynomial. So when you plug it in, you get 0. And if you have a number for which that is true, the number in your numerator has to be a factor of your constant term, that last term, and the number in your denominator must be a factor of this first term. So what this does is it gives you a way to list possible zeros, like things that could work. So the numbers that could work are anything that is a factor of the last term divided by a factor of the first term. Those are like the potential zeros. They might be zeros. And it gives you a list where you could like actually just check them all. That's what this is saying. So what I care from you for this class, and just for like Alex mostly, that you can actually just give me a list of those numbers. Okay? But the thing is that they must be a factor of that constant term divided by factors of what's called the leading coefficient, or the number on the highest power, the one that leads the way. Okay, so let's do that for a couple questions and then talk about how you construct these lists. So the first thing you've got to do is make sure that your polynomial is ordered from like biggest to smallest, so you can see the leading coefficient and the lowest term, the constant term. So, okay, we got that. So now all of the zeros, if they're rational zeros, must be factors of -2 divided by factors of 5. So you can think about a factor as a number that divides evenly into this, a whole number that divides evenly into this. So what whole numbers divide evenly into -2? 1. 1. Both positive and -1 do, right? And also, what else? Positive -2. And how about 5? What number is going to 5? Positive -1, positive -5. And what this means, this is a compact way of writing the list of numbers that could work. And what this means is first you have 1 over both denominators, and then you have 2 over both denominators. So as a list, this is the same thing as either positive -1, positive -1/5, that's taking 1 over both denominators, positive -2, and positive -2/5. Those are all of the rational numbers that could be zeros. They're not all going to be zeros, but they could be. Then you know that, okay, well, 3 can't be a 0, I won't bother checking 3. 5 can't be a 0, I won't bother checking 5. So it's a way of taking an infinite number of things down to 8. And 8 isn't so bad, it still kind of sucks a little bit, but it's not so bad. Do you understand how I got these numbers from that list? Okay, that's the part that I care that you get. Okay. How about this one? So it's factors of the constant term. So factors of, what is the constant term? 1 over factors of 4, right? So what whole numbers go into 1 evenly?
Plus or minus
1, right? So plus or minus 1. Because technically 1/2 goes into 1 evenly, right? So whole numbers. What numbers go into 4 evenly? 1, 2, and 4. Plus minus 1, 2, and 4. And so what that means is we have 1 over all those possible denominators. plus minus 1, 1/2, and 4. I'm gonna write it that way because I'm sick of writing plus minus for every single little number. Yeah, I was just testing to see if you guys are awake. Because you know it's 8:42 on a Wednesday morning.
Someone doesn't sound like she's awake.
Yeah, and I'm not. Okay, so 1, 1/2, and 1/4. Does that make sense? And if you want to save yourself some writing, you can put the plus minus out in front of all of them. So that's only 6 possibilities, right? Okay. How about this one? So do you have to rearrange? You don't have to. Does that make sense? It might be a good idea to do so. Does that make sense? So if we rearranged, it'd be negative 6x to the 4th minus 9x squared plus 4x plus 6. So you have all factors of 6 over factors of what? Negative 6. Great. So what are the factors of 6? 1, 2, 3, 6. I think it helps to list them in ascending order, like smallest to biggest or down, because then it just helps to keep track of stuff if you're systematic. And are the factors of negative 6 any different? No. So plus minus 1, 2, 3, 6. Now, one thing that I know will happen here is you don't want to list numbers more than once. So when you're going through and making your list out of this ratio of things, just keep in mind, like, do I already have that number down? So the first thing that you have is 1 over every denominator. So you have plus minus 1, 1/2, 1/3, and 1/6. Does that make sense? So 1 over everybody. Next comes 2 over everybody. So is 2 over 1 a new number that is not in our list? Yes, write that down. Is 2 over 2 a new number that's not in our list? No, so skip it. How about 2 over 3? Yes, okay. How about 2 over 6? No. Okay, so don't write that one down. So you did the 1, you did the 2. Now do the 3. Is 3 over 1 a new number that's not in our list? I think it is. Because it's 3, not 1. It's 3 over 1, not 1 over 3, right? So we did 3 over 1. Is 3 over 2 in our list already? Nope. Is 3 over 3 in our list already?
Yes.
Yes. How about 3 over 6?
Yes.
Yes. Okay, good. Did that one. And then 6. So 6 over 1. Is 6 over 2 a new number? So it's 3, we already have 3. 6 over 3 is 2, we already have 2, right? And 6 over 6 is 1, we already have that. So there is your comprehensive list. I'm not sure what Alex will say to you if you list something more than once, but it'll probably not say you're completely wrong, probably give you a little hint and say something like, oh, you have something's doubles. Okay. So factors of -5 over factors of -10. Does the negativity affect the list? No, it doesn't. So what are the whole number factors of 5?
Plus or minus 1, plus or minus 5.
Plus or minus 1 and plus or minus 5. How about of 10? Yep, 1, 2, 5, 10. And then go through and make the list. So first we have 1 over everything, so that'd be 1. What else?
10, 1 over 10.
Uh-huh, sure. How about a half first and a fifth next? And then a tenth, sure. That's 1 over everything. Then next we have 5 over everything. So is 5 over 1 a new factor or a new number? Okay. How about 5 over 2? Think so, right? How about 5 over 5?
That's not good.
Not new? How about 5 over 10?
No.
Nope. Okay, so there you go. There's your list of potentials. Okay. So here is how we're going to use that. So there was that one question where I told you that you had a 0 at -2. We're going to use that whole listing technique plus graphing to actually find a 0. So first thing you're going to do is list them. So first thing is list all possibilities. So that'd be factors of 3 over factors of 2.
You were nice and gave us prime numbers.
If I give you this kind of question anywhere, it's going to be prime numbers. It's just too tedious otherwise. So the factors of 3 are plus and minus 1 and 3, right? And the factors of 2 are plus and minus 1 and 2. As your list, that's plus or minus 1, a half, 3, and 3/2. Does that make sense? Okay. Now here is how I want you to find the one that works. I want you to graph P of x. And I think that when you do this, and Alex is going to give you that graphing calculator thing, and you'll be able to graph it. And you're going to look for where does P of x cross the x-axis. And it should be at one of these numbers in this list. What would be another way you could test if the numbers were zeros?
Synthetic division.
Or you could just plug them in and see if you get a 0, right? That would be one way as well, okay? But the thing is, that would still involve plugging in 8 things, and that could get really tedious. So to make your lives easier, I want you to graph it. And if I give this question on a quiz, I'm going to give you a picture. Like I'll probably break it up into parts, and I'll say, okay, list these things, look at the picture, which one's actually a 0, check it by plugging the number in. Does that idea make sense? And then go from there. So I'm just going to tell you the one that is a 0 is x equals 1.5. That's the one that's a 0. I'd hoped it was the whole number, but it's not. Yeah.
So we just plug that whole thing into the calculator and
If you, yes, you can plug this whole thing into a calculator and graph it, or I'm pretty sure that Alex, first, I saw someone doing their chapter 4 homework yesterday, and Alex, when they want you to use a graphing calculator, they give you a graphing calculator, and you just plug the number in, and you look for where does that picture cross the x-axis.
If we graph it and we check the x-axis, doesn't that negligate
Problem?
the point of listing possibilities?
Well, because this will only let you find the exact zeros when you're looking at the picture. We're going to be able to find the rest of them using division, because the other ones aren't whole numbers.
Okay.
Or at least they're not rational numbers, I guess I should say, because that's not a whole number either. Okay, so if you know that's a 0, what are we going to divide by? Divide by x minus 1.5. It's not that bad. X minus 1.5 gets divided into 2x cubed minus 7x squared plus 4x plus 3. So what do you multiply x by to make it match that 2x cubed? 2x squared. So that'll be 2x cubed. What is 1.5 times 2? 3. Be careful with the double negative. Do you see what I mean? You got -7 minus -3. Yeah.
Is this just another way of finding the zeros or what?
Well, we found 1 0. And you use division to factor it down more so you can find the rest. So if you take that away, negative 7x squared minus negative 3x squared, what does that make? Negative 4x squared. Do you see what happened there, Kyle? Yep, okay. All right, then we multiply by negative 4x, right? So we get negative 4x squared. Interesting. Negative 4x squared plus 6x. Take it away. And we get, what, negative 2x plus 3? Whew, and then the last thing, what do you multiply x by to make it match negative 2x? Negative 2. So it'd be negative 2x plus 3. Take it away, your remainder is 0. Is that supposed to happen?
Mhm.
Yeah, you have to have the remainder being 0. And so what you know then is your p of x, it's equal x minus 1.5 times the other stuff. 2x squared minus 4x minus 2. And you want to figure out where is that thing equal to 0. You already know one of them, right? What's 1, 0? 1.5. And the other one you get by solving 2x squared minus 4x minus 2. And what division did is it took that thing that was a cubic and pulled it down to being a quadratic. Do you see what I mean? Or complete the square, right? I'm going to complete the square because it's actually pretty easy. You can divide everything by 2. Does that make sense? And that makes it into x squared minus 2x minus 1 equals 0. I think I also choose to complete the square because it's something that isn't as natural for students and it's a good thing to know for Calc 1, so I'm going to do it whenever I can just to make you practice. So what number do you add to both sides? So I move the 1 over, right? And then what do you add to this side? 1. And the other side also gets a 1. So x minus 1 squared equals 2, right? X minus 1 equals plus or minus square root 2. And so x would equal 1 plus or minus root 2. So those are the other zeros. I know those suck and they're tedious, so as a result, there shouldn't be very many of them. I can't give more than one of those on a quiz because they take so long. So, yeah. Okay. And then the last thing I want to go over is how do you deal with things that have i's in them? So if this was your polynomial, what would your zeros be? What numbers do you plug in and get 0?
Plus or minus.
Almost.
I know.
4 plus or minus 5i. Does that make sense? Those are the things that are the zeros. When you plug in 4 minus 5i, sorry, you can't see that. When you plug in 4 minus 5i, that makes the first one 0, right? When you plug in 4 plus 5i, you make the second one 0. So I want you to multiply these together. And I think that the best way to do this is to first take that negative sign in both of them and distribute it. So make this into x minus 4 plus 5i times x minus 4 minus 5i. I want you to multiply that together and see what happens. So first do the x. What's x times x? Minus 4x minus 5ix. That's taking the x through. That looks like 6, but it doesn't say 6. It's 5ix. What happens when you multiply the 4 through? Or this negative 4 through? You get?
Minus 4x.
Uh-huh.
Plus
plus 16
16, yeah.
plus 20i, right? Next, take the 5i through. You get plus 5ix, right? Minus 20i minus 25i squared, yes?
That I squared is just -1.
And the I squared is just -1, and a whole bunch of other stuff is gonna actually cancel. So you have x squared. Let's look at the thing. Everything that has an I should go away. So this 5ix cancels with that 5ix, right? What happens to the 20i's? They also cancel. So I have x squared minus 8x plus 16 plus 25. Does that make sense why I got plus 25? Because I squared is -1. So that's x squared minus 8x plus
41.
Great. Notice that the zeros for that thing, they happened in what's called a conjugate pair. You got one that's 4 plus 5i, one that's 4 minus 5i. That middle sign between them changes. Those things are called conjugates. Okay, I think we can skip part B. Let's just set up example 12, okay? And we'll stop there. So skip one. Okay, so write a polynomial of degree 4 with real coefficients that has zeros at 1 of multiplicity 2 and at 1, -1 plus 2i. So first of all, you know if there's a 0 at 1, that's multiplicity is 2, you know you've got x minus 1 squared as a factor, right? That part's easy. The tricky part is that the i's and actually also things that have square roots that don't simplify happen in pairs. So if -1 plus 2i is a 0, so is -1 minus 2i. Like that is implied as on the list. So i's always have a buddy, and square roots that don't simplify also always have a buddy. So for the first 0, your factor is x minus the quantity -1 plus 2i. Does that make sense? What's the second one? X minus...
X minus 1 minus 2i.
Yep. And I'm not positive, but if you were asked to multiply that together, the smart thing to do is to do those two by each other first, because then the i's will cancel like they did in that previous example that we had. Okay, but the kicker is that if I give you one thing that has an I, the other one with the opposite sign is also a 0. So if I said 1 plus 5i was a 0, what else has to be a 0? If I said 2i was a 0, what else has to be a 0? -2i, okay?
Is that because I comes from the square root?
It's because it comes from the plus minus part in the quadratic formula. And the same thing is true for roots, like 1 plus root 5 is a root, so is 1 minus root 5. Okay, so they have to happen in pairs. Okay, that's it. See you tomorrow.